Hi there. Today we want to cover the last bit of your syllabus for ionic equilibrium. As you can see here, right? This part here. I, J, K. Okay, let me just explain to you. Short understanding of the use of the concept of solubility product is Ksp. Why is it called solubility product? K, of course. See, the whole chapter here is on ionic equilibrium. See, right? Equilibrium, right? It means that there's going to be a reversible sign. It means it can go forward and backward direction. It's going to have ions, okay? Ions on this side and this side, or ions on one of the side. Normally, there must be ions on this side. Okay, so we're going to see ionic equilibria. So the two important things you must know is, first, of course, is what is an equilibrium, right? If it's in equilibrium, that means it can go forward and backward. Okay, and ionic means one of these parts here, the reagents and the products, one of them or both of them must be ions. Okay, so we're going to deal with this last part here where you can actually see. Okay, so here, concept of solubility product, Ksp, it means this part here is basically for something that will dissolve or dissolve sparingly. It means not very soluble, but soluble enough to give very small values. Now this one, solubility, okay? Of course, in water, in aqueous, okay? So the idea that we are treating substances that are very slightly soluble, they call it sparingly soluble substances. Sparingly soluble substances, okay? And this is where, if you remember, I teach you the solubility rules or laws. Solubility laws. Remember that? Huh? All PAS salts are soluble. This is to do with all ionic substances. Okay, just to give you briefly, okay? All sulfates are soluble except poor big cow, okay? You can add one more here, it's a silver, okay? All chlorides are soluble except what? Poor Adam, remember, okay? Right? And then all hydroxides are insoluble except PAS, okay? And all carbonates, right, are insoluble except PAS. Oh, these we will see here. Of course, there are a few more, right? Talk about other things here. Okay, so the idea is for how soluble the substance is measured by this thing called the Ksp. Okay, now this is a briefing now. So a lot of them will depend on your explanation of how you understand the concept. Secondly, also to calculate the value, because you can see that if there's a K, it's a reversible, you have a Kc, isn't it? This Kc is no longer called Kc. Like in acid and base, you call it Ka, right? Or Kb, or in water, Kw, isn't it? Now, because it's on the solubility product and solubility idea, you go Ksp. Ksp, okay? Solubility product, okay? And of course, the common ion effect, you will see how all these things will tie in three things together. Now let's go straight to the theory, okay? The theory is in page 65. Starting from there. Today I want to go slower. I thought I'm going to finish one shot, but I don't think I want to do that. So I want to spend more time to explain to you so that you will understand. Because the questions come out are very simple and there are three things to manipulate only, okay? Definitions, explanations, and calculations, right? So the first thing, of course, is this thing called solubility products. Yeah, you look at here, 65 now. Okay, here. Right, now I explain here, I have told you, equilibrium means what? There is a reversible reaction. You have got your reagents or reactants here. Right, and there's a product here. Okay, they can go forward and backward. Ionic, I told you, one of them must be ionic. In aqueous means there's water, aqueous. So the first type of ionic equilibrium is homogeneous. That means same. Here, of course, of ions is same means both are dissolved. An equilibrium between the dissolved and undissociated molecule and its dissociated ions. Now this, of course, if it dissolved, right, and undissolved, which means that it have to be like a covalent compound. It's not here. Your weak acids and your weak base, they are soluble. They dissolve in. So dissolve in water. What? No, it's not aqueous. Why dissolve in water? You should know hydrogen bond. So if you filter, you put ethanol acid solid and you mix in water, it will dissolve. You filter it, there's no solid there. So it is soluble. But doesn't mean that it will dissociate completely. That means it will have an equilibrium with all the ions. Remember, it will give you ions. Yeah, see, ions. But it's very weakly ionized. That's why it's called a weak acid. Most of the time is in the form of a molecule, but it's dissolved. So see, homogeneous, aqueous. Okay, now this is called heterogeneous. This is called homogeneous equilibrium of ions, right? Because they're all the reagents here or the reactants here, and both the products here, okay, right, are soluble, right? And one of them is a product here is ionic. So this happens in weak acids, yeah, and weak base, right? So this is what we've done already, okay? So mainly it's for covalent compounds because they can be soluble in water due to formation of hydrogen bonds, okay, which makes it soluble. Right, so of course in this case here, we actually can find a Ka, or normally called a Kc, okay? It's called equilibrium concentration. It's the concentration of the ions, the products here, so here. Okay, and this is called product, times up, okay? And the H plus here, and over this big filler here. Okay, normally this one is put up here because why? It doesn't change much. So we say it's a constant. So it's included in here. That's why we call it now a Ka. It's inclusive of the Kc here. So this is the one. Okay. You will see this happening a lot now. Okay, same thing with the base. Now this one we done already, okay? When we solve our pH and all these things, right? Now the other one is heterogeneous equilibrium of ions. Hetero means different states. This refers to different states. Homogeneous also states. Both are aqueous states. So what does it mean by heterogeneous equilibrium of ions? An equilibrium exists between the undissolved solid. Okay, that means I got my reagents here, reactants here, okay, as solid, undissolved. But somehow it will dissolve. Will give me ions, A plus aqueous. This is solid, and B minus equals so not see, this is a heterogeneous equilibrium, right? Solid and aqueous. Okay, so there's an equilibrium that exists between the undissolved solid and its dissolved species, which means basically ions are. If it dissolve, if it's an ionic substance, if it dissolves, it will become ions. Right? Okay. For covalent substances, it dissolves, but it may not become ions because it remains a molecule. Okay, because the bonds are too strong to break, right? Unless you heat the further. Okay. So ionic salts are sparingly soluble. So we talk about ionic salts here. Okay, I show something. Okay, poor bicarbonate, poor bicarbonate, sulfates here. These are of course lead sulfate is insoluble, barium sulfate is insoluble, famous one. Calcium sulfate is insoluble. Okay, this you used to make your plaster of Paris, or you injure, then you break your bloody head, your bloody bones, and you put a plaster of Paris. Okay, so your chop. Chlorides, okay, lead chloride is insoluble, you know that, okay? Lead iodide also insoluble, the dancing yellow crystal, but silver chloride also insoluble. All these are, going to talk about this, okay? Our chromates, especially hydroxides, carbonates, okay? All these will be insoluble, right? So what does it mean? So there are two terms you need to know. I will talk about, first of all, not the soluble product, but solubility. The first thing you must know is what is that. Okay, what does solubility means? They seldom ask you this definition, but it came out in the paper 5. Okay, and you know the concept of it. Solubility means what? Solubility of a salt, okay, is the maximum amount, very important. Okay, in moles or grams of it, of the salt can dissolve in 1 dm cube, or some people say, some say 100 cm cube also can. Depends, but normally it's 1 dm cube of water to give at a given temperature. So first of all, is the amount that will dissolve. 2, in the solvent, this amount is a solid. Okay, this is solute. Okay, and put it in solute. 1 dm cube of the solvent, this is a solvent. And temperature important. Okay, 3, the temperature. Because higher temperature, more soluble, is not. Yep. To form, 4 is important. Form a saturated solution. That means you dissolve until it dissolves, can dissolve no more. How do you know? Well, a bit. Once you see a bit of the solid remains undissolved, that means I have formed a saturated solution. It means no more can dissolve, saturated. It must come to the point, so the amount dissolved is called the solubility of the salt. It means you can measure how many moles per dm cube, how many grams per dm cube at the given temperature. For example, right? Solubility of silver chloride is this one here, right? It's a very small figure. Okay, you want to put it in figure that you can understand. 5, of course, is 1, 2, 3, 4, 5. So 4 zeros, 0.1, 2, 3, 4, 1, 6, 7, okay, moles for 1 liter. So in 1 liter of water, it can dissolve in so little bit, such a small amount of silver chloride, it can dissolve. And not one bit of solid is there. All will dissolve. This is called the solubility, okay? If you have less than this one here, let's say you got 0.0, this will form at 25 degrees rate, it will form a saturated solution. So if you put less than this 0.000150 moles, this is called a dilute solution. Okay, this is a dilute solution. This is saturated, this one is dilute. That means it can dissolve some more. If you put 0.0000200 moles, this one you get a precipitate. So you put inside here, out of 0.00002 grams or moles you put inside here, right? Only 0.0000167 will dissolve and leave behind 0.0000. How much is this? It's 330 moles undissolved. This will be undissolved, what? Undissolved as what? Solid. That means you have solid that's in equilibrium with your dissolved ions. Okay? So when the solid there, the solution is a saturated solution. Very important. And the amount dissolved is called the solubility. You also have to know that. Okay? So now let's put this here. So we'll completely dissolve from a saturated solution at given temperature. So temperature is very important. Now, I'm going to give you something to think about here. Okay, here. Let's say, to make it easier for us, right? Let's say I got here, okay, 5, say 1, 2, 3, 4, 4, 2, 4, 5. Okay, 5 solutions here, right? 5 solutions here. 1, 2, 3. I just want to teach you concepts, okay? 3, 4, and 5. Remember, silver chloride is insoluble, right? Why? You ask God, okay? Because you know the holding come because of the heat of solution, right? Is too big, because the electric energy is too strong. Heat of hydration cannot overcome this energy. I mean, you learned before, I mean, in measurable form, in explanation of the delta H. Now, mind. Let's say now all this solution here. Now this one. Please understand. I'm giving you hypothetical cases so that it's easy to understand. You must know the concept as well. Okay. So there are five solutions here, and all I say is have a water here equals water of 1 dm cube. Okay. So I want to take my time. So I thought I better use to, otherwise I use first. There you are. Oh, fail. Okay. So today you have a good concept. We try to do a couple of questions, and then maybe next video we finish off all the calculation. Okay, I hope to do at least half the calculation here. Now this water, okay, this is water here. Okay, all 1 dm cube water, and let's say 1 dm cube water, and 1 dm cube water. Okay, so you have 5 of this thing here, and the temperature of it is 25. So temperature is very important because higher temperature it will be more soluble, of course. Why? Heat is absorbed to break up the electric energy of the ionic substances. Remember, all ionic substances, all the ionic substances. Okay, right? They can't dissolve because they're ionic substances, right? They cannot overcome the less energy, isn't it? Okay. Now, let's say now to make, say, a silver chloride, silver plus Ag plus Cl minus Ag. When you put it together, the immediate reaction, that's what ionic reaction gives silver chloride, which you know is white PPT. They will ask you, I'll tell you, color or oil. Okay. So they answer, well, what concentration must it have in order to be precipitated? You will see afterwards, okay? Now, they found that, okay? They found that, let's say I put down here, right? Here. Now, I got two sources now, two sources of silver and chloride, okay? The first source, of course, is silver nitrate. Silver nitrate, of course, is soluble, right? You should know what all nitrates are soluble, soluble laws, you know. Okay, let's say I got here 0. Let's put the in the other way, easier. Okay, easier. 1 times or 1.0 times 10 to the power of -6. Okay, and here the first one I got sodium chloride. Also 1.6 moles, okay, moles times 10 power -6 moles. Right. Now, to define to define the measurement or the physical properties to see whether a thing will dissolve or not, use the word Ksp. Later I explain, okay? I just use it first, okay? So Ksp is a value. Ksp is given as, remember, now this one here, Ksp is written in, you must write the equation correctly. Because Ksp is written in how soluble as AgCl, okay, now watch, okay, now you write this one first, you should write from solid first, going to Ag plus equals plus Cl minus equals, okay? I know I jump over the place, but I want to explain it properly so that, you know, at least you get an idea. Okay. Okay, pause it here. Now this explain this further here, of course, you want to put it plus equals here. Okay, so the K, normally this is reversible. I'm going to put blue pen now. This is reversible. So in any reversible reaction, I can put the Kc now, okay? Okay, Kc, okay, Kc lah, right? Is equal to what? Concentration of Ag plus times Cl minus, okay? Over, of course, my AgCl, okay? Right? Because only very small dissolve, this is not constant. So constant normally can put up here together with this one. So I get Kc times my silver, whatever amount is okay, okay? Is equals to Ag plus and Cl minus. Okay, now this whole thing term is called the Ksp. So Ksp is basically the ionic product. It's called the ionic product. Ionic product. Okay, ions what? Product means times it. Ionic product. Okay. Okay. So this part is called the ionic product. This part is called the Ksp. The solubility product is called the solubility product. Just to solubility product. Just to tell you the difference again. Okay, ionic product, solubility product. Now, they found that in this case now, you can only write this equation here if the system is now in a saturated solution. That means what? That means there is going to be the solid left behind here. Okay, in the system here, there's going to be solid. If there's no solid, very hard, unless you know exactly how much is it. So to be sure, in experiments, the dissolve and there's some solid behind. Oh, that means it's a saturated solution already. Okay. So this can only be written for a saturated solution. Okay. So remember in a saturated solution, the ionic product of all the ions here is equal to the Ksp. So let's say the Ksp here by definition, okay, Ksp of your silver chloride here. Let's say I give to you that. Let's say make it simple. 1 times 10 to the power minus 10. Okay, that means this is the constant mole squared dm minus 6. Okay, let's say okay. That means once when the ionic product when here, right? And this Ag plus times Cl minus here in a solution reaches this value here. You say, oh, it has reached a saturation point. Okay, cannot dissolve anymore. But before this, if you have a less than this one here, less than 1 10 power minus 10, it means it can dissolve some more. Okay, right? It means less than 1 is what you call a dilute solution. Like put down here. Okay, see now. See, if the ionic product, okay, is less than kurang, okay, Ksp is a dilute solution. More can dissolve. If it's equal, to the Ksp value here, it's a saturated solution. Remember, at a given temperature. But if it's greater, if your coverage is greater, that means that there will precipitation will occur. You can calculate, let's say you heat it up, okay, more dissolved, and then you cool it down. Oh, as you cool down, the fluid come up. Solid come up, called crystallization. Why? Because the concentration there exceeds the Ksp for the temperature. Okay, so the precipitation occurs until this is reached. Now let's say I keep it here. Okay, I'm saying about five beakers here, and I keep a temperature constant. Okay, so the first one here, I add in this fellow here. Both are soluble salts. Of course, silver nitrate will dissolve to give me what? Completely, right? Because it's very soluble. All this is soluble. Give me some here. Of course, and the time equal to 0 is 0, 1 times 10 power of minus 6. So at time equilibrium, no more, all dissolve. This will give you 1 mole is to 1 mole. So give me 1 times 10 power of minus 6 here. So 1 times 10 power of minus 6. Okay, right? So same thing with my sodium chloride. Okay, will dissolve to give you completely because it's completely soluble. Once when the iron substance dissolve, it will form ions. Right? It cannot leave behind any solid. Okay, because it's a lattice. Okay, so time 0 is equals to 1 times 10 power of minus 6 is 0, 0 at 0, 0 at the beginning. At time equals to equilibrium, no more. Habis. So this is 1 times 10 power of minus 6. It's 1 times 10 power of minus 6. Okay, so in this case here, right? In this case, if I put these two inside here, okay, right? Sodium, I'm going to put green color. Sodium and nitrate here are what you call spectator ions. Okay, they won't do any problem because they are soluble substances. All nitrates and all sodium salts are soluble. Spectator ions. Okay, so I'm going to do some practical theory explanation. Okay, so it's between this guy and this guy that's going to be PPT not because we know that silver chloride is a PPT. So now the point is, will it be PPT not? So when I put this stuff here, right, I will find that I know that the Ksp expression, right, from here, right, is equal to this one here. Yeah, here. Well, here. Oh, I put it here. So the Ksp expression, they will ask you for expression. Okay, basically, how to write the Ksp expression? Very simple. Okay, I'm going to use the red here. Okay, so easy to see. Okay, how to write this is called expression. You can see expression is a regular question of Ksp. So to write it, obviously you need to write the equation first. So silver chloride solid, okay, plus equals you want to put because but no need one, okay. Reversible give you Ag plus equals plus what? Cl minus equals. It means if it will dissolve very small amount. So remember, it's an ionic product, okay, plus times product Cl minus this one. No need to put under here, okay. This is the one here. Okay. So now I want to find whether this one here will precipitate or not. So I put inside here, of course, in this case here, right? The concentration Ag plus and Cl minus, what is it? It's equals to what? 1 times 10 power minus 6 times 1 to the power of minus 6. Equals how much? 1 times 10 power of minus 12. Which is less than my Ksp, is it? No, Ksp, given here. That means what happened? Will it be PPT or not? No, it's a dilute solution. I'm going to put here green color. Okay, this is the dilute solution. Why? The Ksp value, the value at times here is less than 1 times 10 to the power of minus how much? 10. Is that? Okay. Now the second one. The second one here. Okay. Inside here. I'm going to put solid. Okay. Silver nitrate now. Solid, I'm going to put here 1 times 10 to the power of minus 5 moles. I put sodium chloride equals the same. Okay, so all will dissolve, all will dissolve. That means my silver ions will be how much? 1 times 10 to the power of minus 5. So also my chloride ions also what? 1 to the power of minus 5. So the ionic product for here, right? For here, how much? Will be for silver is 1 times 10 to the power of minus 5 times 1 to the power of minus 5 is how much? Equals to 1 to the power of minus 10. Oh, That means that this is a form of what? A saturated solution. Any solid? No solid yet. Because just nicely. Okay. Now here I'm going to add in here. Okay, now just to make it more dramatic, okay, I'm going to put a different color, blue color. All right, I'm going to add in silver nitrate here. Okay, we're going to put same one, easier for you to remember. 1 times 10 to the power of minus 4. Sodium chloride, 1 to the power of minus 4, means more concentrated. Therefore, okay, so silver ions will have this concentration, so will Cl minus well. So what will be the ionic product here? What will be the Ag plus and Cl minus here? Be 1 times 10 to the power minus 4 times what? 1 to the power minus 4. Because what? 1 to the power minus 8, which is bigger than this one, see? Right or not? That means that it will be precipitating. You will find the thing precipitate. Okay, until the concentration of this one here will be equal to my 1 to the power minus 10. That means it will form a saturated solution and solid. So I get solid here. I get solid silver chloride plus a saturated solution of silver chloride. Is that clear? See now? That's how Ksp works. That's how Ksp help you. Okay. Now, how about if now I do a different thing here? Okay, now because of here, I'll put here, okay. Okay, I'm going to put silver nitrate here as 1 times 10 to the power of minus 4. Okay, moles. I'm going to put here sodium chloride is equals to 1 times 10 to the power of minus 6. Okay, put inside here. What will happen? Would there be any PPT now? Now, because I know that my silver ions concentration is how much? 1 to the power minus 4. My Cl minus how much? 1 to the power minus 6. So the ionic product, okay? My ionic product is how much? Ionic product, sorry, it's all over the place. I'll rub this off first. Okay, so my ionic product is what? Ag plus is 1 to the power minus 4 times 6 is equals to 1 to the power minus 10. Exactly same as the Ksp, isn't it? Right on. So it is a saturated solution. Here is saturated solution. Any solid? No solid. Okay, right? So what I'm saying is they can come from different sources, different. The concentration are different, don't be the same. Unless come from the same source, 1-to-1 ratio. Minus 4, minus 6, as long as the ionic product minus 4, minus 6 times going to give you minus 10, you can say that, well, it says rich Ksp or have not reached Ksp. So finally, is the ionic product. You type this 2 here. Okay, is it reached the Ksp? If it reached Ksp, that means that it is saturated. If it's more than Ksp, it will precipitate until the solution form a saturated solution. If it's less than Ksp, that means it's a dilute solution. It's not. Now final one. Okay. Right. So if I add silver nitrate, okay, equals to 1 times 10 to the power of -6, and sodium chloride 1 times 10 to the power of -5. So will there be a PPT? Your good guess. You add, when you times 2 further here, you get the power -11 here. So it's less now. So it will be a dilute solution. Okay? Cannot. Right? Now, so they will give you a whole panoramic view of what it means, okay, to achieve a saturated solution and how to calculate the Ksp of a sparingly soluble ionic substances at a given temperature. You can look at it again, okay, try to go again. I know it's all over the place, but it's quite systematic. Okay, now let's see how we're going to do this. I explain one here and how we can do it, okay? Now, this is very simple, but the math is simple, but the math is tricky because of the ratio. Okay, now the solubility of calcium hydroxide, of course, comes to the CaOH2. Right? Remember, in water is, okay, 20 degrees centigrade is this, how many grams per dm cube? So it's always per dm cube, this is in grams. So remember, in equilibrium, in Kc, always was equal in moles, okay? That's what moles, okay, moles per dm cube. So you can change the values. Okay, what is a solubility product? This one is the Ksp. This is a solubility. Maximum amount that can dissolve 20 degrees centigrade is this one here. This is a solubility. Okay. So you change the number of moles over 74. This is 74 here. Okay. This is the MR. Okay, of calcium hydroxide. So it's number of moles. Of course, it means the solubility is good. This means this is a solubility of calcium hydroxide. At what? 20 degrees centigrade. Yeah. Okay. So now always start with the equation. All right. The equation for solid product is always that the solid is here. Remember. Okay. You will dissociate this solid here. This equals here. And equals here. You will always dissociate, give you the ions. Okay. It means it will forward is dissolving. Soluble, okay? Go backward is precipitating. This precipitating. This solubility. Okay? So this is how you write. So of course, the expression, my dear friends, is always, right? The species, remember, this is of the species. Not on the amount yet. It's amount, but you must say that it's of the species. So it's the concentration of the species of calcium 2 plus and the species. See the 2 here, you don't put the 2 inside here. You don't. Never. The 2 you can put when you calculate. Like here, I'm going to do it here. Okay. So you put the species, okay, OH minus 2, the 2 in front here. Remember? Right? Remember now, this is the law of mass action, okay, the equilibrium Ksc. So now this is the expression. You see here, they ask you, I'll show you all the expression, okay, here. Right? You can see right through. Okay? Write an expression for a solubility product of valence sulfate. Very simple. So obviously, this is how you do it. Yeah. So right here, the equation, right? And of course, Ksp, right? The whole thing, of course, if Kc will over what? Barium sulfate here. And this is wrong. You put Ksp, it's wrong. So I must put up here and change it to Ksp. So this is the correct one. Okay? See here. See the marking scheme. See? Okay. Right. Ksp is on here. It's just an ionic product. Now, this part is called the ionic product. Remember? Ionic product. It's called the solubility product. So the words are very important one. Solubility product. Okay. So they ask you for units as well. Okay. Remember, it's moles per dm cube, right? Because Kc is moles per dm. Two of it is mole square -6. Okay. So expression always come up. Okay. And not the other one here. Write an expression for Ksp for magnesium hydroxide. Same again. Okay. So write this one first. Okay. Of course, you put solid there. Okay, I was in a hurry and take me 5 hours to do this. I tell you, you fellas all don't know how hard it is to prepare these things. I tell you, idiot. Okay, so Ksp, right? Only species. Don't put the 2 here. Full. Don't put 2 here. You put 2 when you calculate. Okay, later I show you. Okay, now species only. Species, and put the 2 up here. Okay. Same thing here. Now, of course, the harder ones, let me show you. They already come all the time. See, okay, yeah, see, species only, okay? Right? Let me just show you, see again, right? expression. Always come out the first thing, ask for expression. No, expression again. Expression. Right. Cross here will be the units. Okay. So I want to show you all the use here again, species here. Okay. 2 here and put 2 here. Don't put the 2 inside here. Don't put that. Don't put the 1. Okay. All right. Now I'll show you some. Okay. Again here. Then correct here. Now I'll show you some. Well, more. Okay. More. Let me see. I thought I got it here. Solubility product. Okay. Okay, page 21. More, nothing difficult, more different. Okay, that's it. Phosphate ions in water may be removed, adding a solution containing calcium ions, which form a precipitate. Precipitate means calcium phosphate. And we give because phosphate is 3. Wrong here. See, Mr. Levels make mistake. I tell you, so shameful. Okay, phosphate is 3 here. See, fast. I tell you, you guys don't know how I suffer there. Okay, phosphate, okay? Right? So that's why it's calcium 3, PO4, 2, okay? Phosphate is 3 plus, 3 minus. So equation, okay? So easy there. Just give up this stupid thing, okay? Right? So how do you write now the expression? Very simple. Calcium, the species, 3 is the mole ratio. Put 3 on top here. Phosphate, the species, 2 is on top here. Simple thing, right? So here, see here. All right, here. Ca2 plus 3, phosphorus 3 minus 2. Right? So these are the harder ones. So to say that. Now our difference is 23 here. You can see here. This is quite simple. Silver 2. Just change it. Ag2. Okay, here. Okay, here. Right, silver phosphate here. The numerical value for Ksp is blah blah blah. Calculate Ag plus concentration. Okay, here I see standard solution of your silver phosphate Ag3 PO4. Okay, obviously Ag. This one will give you what? Put down here 3 Ag what? Positive. Yeah. Positive plus what? PO4 minus 3. It's not. So what's the Ksp? Don't care about this for here. So Ksp is what? Ask for expression. Yes. Ag plus and power 3 and phosphate minus 3 power 1. That's all. That's not. Second here. Yep. Units, the 4 of them. So more power 4 times minus 3 is minus 12. Okay. So all these come in different ways. Okay. Remember, expression is very important. So in this case now, some more. So first of all, I show you the expression. Okay, Ksp is the concentration of the species. And then the power here is for the stoichiometry of the equation here. Here's 1. So here's 1. Here's 2. Here's 2. Okay, now, to put the concentration correctly, you need to go back to solubility. Always, I will repeat this, always start with this statement. You see, some students are just think they're damn bloody smart. And they make mistakes. You idiots. Something simple, follow lah. You think you're damn smart. Okay, you fail, don't blame me. Because you can easily make mistakes here, because I know I make mistakes. I said, why I do this stupid thing, a stupid mistake, you idiot. Because we don't start with the correct assumption. Always start that the solubility of calcium hydroxide be X moles. Very important, X moles per DMQ. You always X one. It means X moles dissolve. X moles dissolve. You always start with X one. Okay? Now when X moles dissolve, if X moles dissolve here, you see here, right? If X moles dissolve, time goes to 0. Okay, I'm going to rub it off here just to make it easier for you to see. I did all this so that I explain. I don't make any stupid mistake. I did last one. Stupid mistakes. Okay, I'm not going to go very fast. As I said, I might take two sessions. Never mind, doesn't matter. Okay, time 0. Time 0. I put in here let's say X moles dissolve, okay? X moles. That means at time 0 is 0, 0 here. It means before dissolve is X moles. After dissolve, right? Equilibrium, okay? Let's say this dissolve. That means no more. No more. Here, of course, when dissolve means no more. It means one more give you what? One more, two more. That means let's say if here, right, the amount dissolved is on here. That means this one here, I put 0.0376 moles here. It all dissolved, that means no more. Of course, there's solid there. Okay, don't care about the solid. Okay, that means here, if this dissolved, that means how much is this? 0.0376. Or if X was dissolved, this X. This is what? 2X. That means 2 times 0.0376. Now, this is the amount of the species. The X is very important, so 2X. So actually, in calculations, your Ksp is equal to what? X times up 2x power 2, you know, so the 2 and 2 here must be there. Otherwise, you leave out the X, the 2, you die. I tell you, you die standing, you fail, man. I tell you, okay, no? Make sure put this here because you're going to put inside here and then put inside here. So there are 3 points here 1, 2, and 3. Otherwise, you make a mistake. So it's equal to what? It's equal to X 4x squared. It's equal to what? It's equal to 4x cubed, you know, equals to Ksp. Yeah. So Ksp is equal to this one here. So here is 4 and your solubility is how much? They tell you this one here. Okay. 0.0376 cube. If you don't know, do this, then you go to the third one. Let it go then. Okay. So this answer. Okay, use cube. For that, times 4, this is the answer. Okay, remember things here. Now with this, we can go on already. Okay, right? These are all examples. Okay, now I'm going to, with the 20 minutes left or 15 minutes left, whatever, I'm going to go as much as I can. But before that, I need to talk about myself finishing the theory, okay, on this thing called common ion effect. Because then we do all the questions, we don't have to come back this again. Okay, now this is quite a good axiom from the students. They come talk, and say, hey, let's write this out. In a saturated solution, the concentration of ions, Ag plus and Cl minus will remain constant irrespective of the amount of sparingly soluble salt. That means that you put 1 gram inside, 2 grams inside, 5 grams, 1,000 grams inside here, the Ksp of the solution is always saturated at the temperature and is always remain the same. You know what I'm saying? That means here, okay. Here's 1 dm cube. Here's 10 dm cube. Here's 1,000 dm cube of water. Here I put 10 grams of silver chloride. Here I put 1,000 grams of silver chloride. Here I put 1 million grams of silver chloride. Okay, stupid is it? They all here, of course, all of them will not dissolve there, but the amount dissolved here, right? The amount of silver ion dissolved here and Cl minus dissolved here are different because of the concentration. But when you times it out, when you times the Ag plus the concentration of this one here and Cl, of all these 3 solutions here, it will be the same because it has reached a saturated solution. It is a constant at a given temperature. Temperature 25. Constant. Okay? Right? Okay, this is what it means. Right? This will be a constant. That's a beautiful thing about it. So you put more inside here, it won't dissolve, it would be a solid. Okay? Right? Because it reaches a saturation point. And the ionic product of Ag plus and Cl minus is equal to the Ksp value at the given temperature. Okay, so now the other one, of course, is this called common ion. Now, remember, they will actually use this common ion. They want to use this word common ion. Ion is common, okay, and it's the Shuttler's principle. I'm going to show you the word here, this 69 in the syllabus, and they want you to use it in your explanation. See here? Show an understanding of the common ion effect. So don't think Cambridge put this word down here to decorate the paper, no, you idiot. That means they want you to know. They want you to use it if possible. And they will use it in marketing scheme. Worst of all, not best of all. At least you know one different one. Okay? So 670. Okay. Okay, now there's this thing called, what's the use of this thing? Very simple. Now, see, common salt, sodium chloride, bad for your high blood pressure, okay? Good for taste only. So limit your sodium, okay? It comes in seawater, no? And seawater contains sodium chloride, calcium chloride, and all these are good minerals actually, right? So your body needs them. Right, but these two, if you find these two in your, if you find these two, for let's say in your table salt, you absorb water. It's called deliquescent, absorb water. So it become wet, you know. So like in the Western, you have these salt shakers, right? It must be dry, otherwise one hole there, how come out? Okay, you know, pepper got 3 holes or 5 holes, but salt one hole. Salt, they call it a salt shaker. So of course, when you put salt inside, it must be dry salt, and so the dryness is that you need to eliminate these two for this here. Okay, so how do you eliminate them? Very simple. Now remember, you get your brine solution. So this is from seawater after heating for a long time. It's very concentrated already. So I want to get this out. So what? So they put in, they bubble. So remember that this is the common. Well, this is equilibrium. Yeah. I know it's a very soluble salt, but still there's still equilibrium. So I don't put something common inside here. Okay, so the bubble inside here HCl. HCl is acidic. You form H plus and what? So this fluid here will increase the concentration, right? So remember it's in equilibrium already. The Kc is constant already. You put increase that, it will go backwards, it will shift backwards, right? And you form the salt, it will precipitate. That's why it's called precipitation of the salt. So it come out and get some here, and you filter off. Common ion effect. So the increase of, so how do I explain? The increase of what? A Cl minus, right, will cause, okay, the common ion effect will cause the equilibrium to shift backwards to the left. That's all. Okay, increase in concentration will common ion effect. I show you how to look at it. Ion effect will shift equilibrium backwards. Now, let me show you how the answers are. Okay, you can see how the answer here. All right, quite often asked. So I did see due to common ion effect. Okay, right, precipitate will form. Okay, we'll shift here, shift to the right. Put the equation or shift to the left. Due to the common ion effects, now the underline black here, which means that you need to write the word there. Okay, right? See here again. No, here, okay. Always common one. So you better get prepared for it, okay? See again. Common ion effect. Increase in cell, right? Okay? Force solubility to shift over to the left. It's better to put the equation here. Okay? So remember, so of course, is to purify your common salts so that it won't become wet. Soap. Remember in your form 5, you learn how to make soap, isn't it? Right? Sodium stearate. Okay, you boil your palm oil here, palm oil. Okay, with sodium hydroxide. Okay. You boil, and you form your sodium stearate, which is a salt. Right? It's soluble. So how to shift it backwards? Okay, because all solutions are soluble. So you put salt inside here. It's called salting out of soap. Salting out of soap. Put sodium chloride here. You increase the concentration of Na plus, what happens? Equilibrium will shift backwards due to common ion effects. All right, now enough already. So with the next 15 minutes or so, let's try some questions again. This one we will do. Okay. I finished the theory already. Actually, I can stop now. Then you all do whatever you want to do, and you fail. Okay. All right, now it's all calculations. Okay, now let's do the first one. Okay, so I finished the theory. So calculations, I will take another session tomorrow. So I say I prepare 5-6 hours. You think easy? Mr. Lam, I can do it. Holidays. You all never know you do your work. You fail, you disgrace me, I tell you. Now I'm enough scolding. Barium ions are poisonous. Okay, right? Patients with digestive and tract problems are sometimes given X-ray. after they swallow barium milk consisting of suspension of barium sulfate. Remember, sulfates are poor big cow, it's insoluble water, isn't it? Right? So actually what they do is they want to check your stomach for any ulcers now. So you must fast for 1 day, whatever. No? So just drink water. Then they ask you to drink the paste, like some paint, it's pasty water. You drink it, you will swallow it. It's all insoluble, right? By making a creamy soup kind of thing. And you swallow it, they call it barium milk. Yeah, and it's barium 2+ in saturation solution of barium is too low to cause toxicity. Wrong, now they found it's very toxic. So scientific fellows here now found too late. A lot of them are poison. Anyway, so now they don't do this, they do endoscopy. Easier. Just put a bloody hole blood tube into your mouth and go into your stomach and check whether you got any ulcers. That's the easiest one. No problem with any poison things. Okay, so this very old technology, but hey, it saves lives. You poison a bit, you get vomit, whatever, but you save life. Okay, so this barium sulfate is insoluble. Okay, right? Too low to cause any problems. It's wrong, And now they say, they do cause problems. Write an expression for a solid product of barium sulfate. Okay, so that's what you do. Remember, sorry over here. Okay, because it doesn't matter. So it's just concentration. Okay, most per dm. Okay, very simple. Okay, 1 to 1. So then they say the numerical value of Ksp is this. Calculate the Ba2+ in the solution. That means that this Ba2+ is the concentration of the solubility. That's where now it comes out. Okay, I told you already. First of all, write down this equation. Okay, remember the solid over here and then the ions over here. Right? Then this axiom, don't be stupid, okay, and then think you're damn bloody smart and don't follow what I say. Let the solubility of barium sulfate be equal to X moles per dm cube. Very important. So put X here, X moles per dm cube, absorb you X here and X here. Then you're safe. Okay, so the concentration of barium is X moles per dm cube, sulfate is X moles per dm cube. So in this case here, right? So you put here, all right. So remember, I just skip one page here. So here, so the Ksp is 1.3 times 10 to the power minus 10 is equals to X times X. Yeah? Yeah. So X squared is it? It's right here. Okay, root here is answer. Simple, isn't it? So 1.14. 1.14. Yeah. Okay. See root. Okay, moles per dm cube. Always put even though the bracket here because you got it here already, but don't care. All right. So some common sense question. The numerical value of Ksp for barium carbonate. So this see the smaller the value, that means the less soluble. Okay. So they ask the question: the smaller the value here, the Ksp, the less soluble. So this barium carbonate also is very insoluble. So why not use barium carbonate? Okay, it's not significantly higher than barium sulfate, but barium carbonate is very poisonous if ingested. Why? Because in the stomach, HCl will give you your barium chloride, which is very soluble, isn't it? All chlorides are soluble. Well, all chlorides are soluble except radium. So you will die. They will die faster. Okay? Right? Now here the second one. A useful commercial source of magnesium is seawater. Well, where magnesium Mg2+ is. So in the seawater here, let's have seawater here. Okay? Right? There is magnesium. The amount of magnesium here, the concentration here in the seawater is equal to what? 0.0, quite a lot. No, that's why you eat it. I drink magnesium chloride out. This is from the sea. Okay, quite a high concentration. How do you get it out? Magnesium is specifically insoluble by adding calcium hydroxide. Get out calcium hydroxide because all hydroxide is soluble. So I put this line here. Come out. Okay, right. So it comes out as magnesium hydroxide. As it comes out, it means that inside the solution here will remain magnesium 2+ here. And OH minus here, and you'll form what? A saturated solution. It means if solid come out here, right, as magnesium hydroxide, what is inside here is there's still magnesium 2+, of course, and your OH minus. And these two here will have a Ksp at that temperature. This is what I'm talking about. So write an expression for Ksp for MgOH2. Okay, so here write your equation here, right? So this is the equation. Now here, the numerical value for Ksp of magnesium hydroxide is right here. Calculate the Mg2+ in the saturated solution. That means what remains here in the saturated solution. Okay, very simple, isn't it? So again, let the what solubility be X0. Very important, So if X moles dissolve, so this X, how much is? What is 2X now? So of course here, in this case here, this is X times what? 2X square, my friend. Don't make this 2 and 2 here. Don't put 2 in front here yet. Put here. So here's 4X cubed equal to this end. X equals to root 3. Answer 1.7. Okay, the maths you don't know how to do, I don't care. 1.7. See now? Okay. Right, now the last part here. So what is left behind? Left behind is this one here. Left behind, magnesium left behind after precipitation. Okay, left behind. Okay, because it's a saturated solution. So you must understand the theory behind it. Okay? Then here, hence calculate the maximum percentage of origin magnesium, right? In that is this one extracted. How much is extracted? So this left behind, okay, left behind is 1.7 10 power minus 4, okay, percentage over the original more 0.054. So it's some percentage of left behind in the saturated solution. So the percent extracted will be 100 minus that. So 99.68% has been extracted. Okay, right, minus that one. All right, 99.7. 0.7, yeah, 0.768, 99.7. Okay, so go back and go through it. This how comes up. Okay, let's do one more. Okay, monuments made from marble or limestone, such as Taj Mahal in India and the Mayan temples in Mexico, are suffering erosion by acid rain. The carbonate stone, because limestone is converted by acid rain to relatively soluble sulfate. Okay, so the carbonate, the calcium carbonate is more soluble. Okay, so limestone dissolve, come up. Expression for calcium sulfate, simple, isn't it? So write the equation here, and these two down here. All right, easy, is it? Okay, you can see that. Skip. Okay. Second part. All right, the Ksp for calcium sulfate numerical value, blah blah blah, 3 to the minus 5. Use the expression in 1. Correct this one here. Very simple. Again, what? Solubility of calcium is X. So X here. X moles dissolve, so it's X moles here. This X moles here. Okay. So this one will be X and this X. So it's X squared equals to this one here. So X equals so this can find X. X is solubility, same as this case here, SO4, same as CO2 plus. Okay. So this is same as this one here. So same. Okay. So it's the number of moles. Okay. Right. So this is the more difficult part. Hence, calculate the maximum loss of mass of a small statue if 100 dm cube, but not cm cube, bloody fool, even blind cows of acid rain is false on it. Assume the saturated made of pure carbonate and the acid rain becomes saturated. Okay, that means one statue here. Okay, one statue here. Okay, right. For 1 dm cube, 5.8 10 to the power minus 3 moles will dissolve. Get from a saturated solution. If here instead of 1 dm cube, fall inside here, how much? 100 dm cube. Okay, so it dissolve more then. So here 1 dm cube is so much, dissolve, not so much. So this is the number, yeah. Okay, so this over this times this, which is this one here. Okay, they ask you for mass, and this was in grams times your MR. This is the amount. Okay. All right, I think I will aim with this. Write expression for Ksp for barium sulfate. Use the data to cover its value. Very simple. Okay, so barium sulfate. Yeah, for this question. Okay, see, barium sulfate is much less soluble than calcium sulfate. A saturated solution. See that? This is called what? This is called the solubility, isn't it? They don't tell you, but you must know solubility of barium sulfate is 9.0 times 10 to the power of minus 6. It's the solubility. Okay, so here, right? So this is the equation, right? Expression is the expression. Okay, and then use it the Ksp. Okay, so this X moles, So solubility with x moles per dm cube. So x here. So x squared equal to this one here. So root lah. Okay. So root here. So x is equals to root 9 times 10 power of minus. Sorry. What am I? That's the square, okay? 8.1. See, I even make mistake. Hurry. Okay. Yeah. 8.1. Okay. So I finished here already, but I would tomorrow. I think I'll do one more. See, I'm lazy now. Holidays now. Anyway, Merry Christmas and Happy New Year. Okay. So I see you next day. See you back in school. Okay. Bye bye.